Hello and welcome to Neo Psychology with me, your teacher, Mr. Neo, the channel where I teach online psychology lessons to my wonderful students. Today we're starting a new unit, which is Research Methods, Year 1 content, and we are starting with Lesson 1, the experimental method. What is the experimental method? This is what we're going to be finding out today. Let's get started, shall we? Little energetic that was. Here we go. Research methods, the experimental method. How could you investigate these questions? So we've got someone on the right who's having a look and she's got a few questions. Does 10% of the population suffer from depression? Does smoking weed cause schizophrenia? Are men more aggressive than women? Lots of good hot topics there. How could you investigate these questions? Think back to your GCSE science, right? This unit of research methods is going to show you some of the methods and techniques that psychologists use to answer questions about human behavior, right? Here are some of the keywords we're going to be learning today: aim, hypothesis, independent and dependent variable, and operationalization. This should be familiar. With you of your GCSE science. Let's get started, shall we? Here are our learning objectives for today. We have learning objective 1, show comprehension and apply knowledge of aims. Learning objective 2, identify and analyze hypotheses. 3, to be able to differentiate between dependent and independent variable. And then 4, to understand how to operationalize variables. We've got 4 learning objectives today. Let's get started on number 1, show comprehension and apply knowledge of aims. Psychologists use a number of different methods and techniques to conduct research, and that's what this chapter focuses on. That's what these lessons have a look at. Psychologists are able to draw upon a number of different methods as part of their research, but one of the most often used is the experimental method. Here's the definition of experimental method. Let's try and go through it, fill in the gap. It's a gap fill activity. The support words are on the right. Let's try and fill them in as we go along, right? Fill them in with me. Do it before I tell you, right? Here we go. Experimental method involves the manipulation, I'm going to go with. Did you say that? Liar. Good. Manipulation or change of an. You won't know this yet, but we're going to know by the end of the lesson. An independent variable to measure the effects on the other variable, which is the dependent variable. Very good. Experiments may be, so these are types of experiments. Laboratory, so in a lab. Field, which is outside the lab, essentially. Natural. And quasi. We will find out what these are in a later lesson. Experimental method involves the manipulation or change of an independent variable to measure the effects on the dependent variable. Experiments may be laboratory, field, natural, or quasi, right? We're going to have a look at what these words mean in a little bit. Let's start with the aims, though. So this is page 178 and 179 in your textbook. Aims. We have a theory. So I'm going to give you an example. This is the hypothetical that we're going to use in this lesson, right? It's a hypothetical experiment. We have a theory that energy drinks affect how much people talk. This is based on our understanding, having read a few research studies on the internet, that energy drinks contain sugar and caffeine, and that these substances increase alertness, making people chattier. I might also get this from some of my own personal experiences. I might have that understanding. As psychologists, we've been paid to investigate how the energy drink Red Bull might affect the talkativeness of those who drink it. So a big company's come up to us, let's say Red Bull or someone else, and they've gone, right, we want you to show if energy drinks like Red Bull affect the talkativeness of those who drink it. Will it make them more chatty or less chatty? Will it affect the talkativeness, right? And this is what we're going to do as scientists, as psychologists. This is what we're going to investigate now. This is the experimental method. This is how we do experiments. Now that we have an initial idea, the next step is to narrow the focus of our research to produce an aim. In psychological research, aims are developed from theories. like our energy drink theory, except in psychology, the theories tend to be much more sophisticated, oh yeah, and based on many more hours of research. Aims are general statements, right, that describe the purpose of an investigation. In the case of our investigation, the aim would be something along the lines of to investigate whether drinking energy drinks makes people more talkative, right? That would be our aim. To investigate whether energy drinks makes people more talkative. Okay, what is an aim? All right, another gap fill. What is an aim, right? If this question came up in the exam, how can I say what an aim is? It's difficult. It's difficult to give a specific definition. Yeah, I know. I sort of know what it is, but it's difficult to put it in words in a nice round definition like I've got here. So, an aim is I'm going to go with general statement of what the researcher, yes, intends to what? Did you say study? Well, you're wrong. It's investigate. The purpose of the study. There we go. We did it together. I did it. Aim. A general statement of what the researcher intends to investigate and the purpose of the study. What is the purpose of the study? What am I aiming to investigate? And that's the aim, all right? There we go. We know what an aim is now. We probably knew before, but it's good to go over it. Identify one thing you learned about aims. Did you learn anything about aims? What's the one thing you learned? Why do you think learning about aims is important? And how does aims apply in real life? How does learning about aims, or how does this aim apply in real life? Well, it applies in real life if I was to do an investigation. If someone was to pay me to do an experiment, I'd have to label out what the aims would be, and I would let the company that are paying me, well, what will I aim to find this? Brilliant, well done. What questions has aims raised for you? What are you still wondering though? You got any questions about aims? Write them down or type them into the comment section. Maybe I'll reply, maybe another student can reply and answer you the questions, right? And there we go. That's learning objective 1 complete. Show comprehension and apply knowledge of aims, right? Can we tick that off? Let's tick. Done. That's how this works. Let's move on to learning objective 2. Identify and analyze hypotheses. Hypotheses, that's the plural of hypothesis, right? Hypotheses. Hypotheses. Having written an aim, we now need to formulate a hypothesis. A hypothesis is a statement that is made at the start of a study and clearly states the relationship between variables as stated by the theory. Essentially, it's a prediction. What do you predict would happen, right? In the case of our investigation, this would be, for example, it could be drinking Red Bull causes people to become more talkative, right? That might be my prediction. That might be my hypothesis, okay? Drinking Red Bull causes people to become more talkative. Yes? Right, so what is a hypothesis? Again, let's fill in the gaps. Let's do it together, right? Do it before I say, okay? Hypothesis. If you want to pause it to get this down, pause it and then go through on your own, and then I'll go through the answers now, right? Hypothesis. It's a clear, precise, testable statement. Yes, I got it right. I should do, I wrote it. That states the relationship between the two variables, between the variables, 2 or more, could be more, to be investigated. Stated at the outset or the start of any study. So I have a hypothesis, I've got a prediction, right? A clear, precise, testable statement that states the relationship between variables to be investigated. Stated at the outset or the start of the study. So our hypothesis was drinking Red Bull will cause you to be more chatty, will cause more talkativeness. I hypothesize that the more students revise, the better grade they will get. That will be another hypothesis, right? Whether that is true or not, it's definitely true. But we haven't done research into it, so we can't come to that conclusion yet. But it's definitely true. Hypotheses can be directional or non-directional. Ooh, you're getting into uncharted territory now. What is this? What is this directional, non-directional you speak of? I'll let you know. Here we go. In a directional hypothesis, also known as a one-tailed hypothesis, the researcher makes clear the sort of difference that is anticipated between the two conditions or groups of people. For this reason, directional hypotheses include words like more or less, higher or lower, faster or slower, etc. So to use the example we've got here, with the Red Bull, you could say people who drink Red Bull become more talkative than people who don't. That would be a one-tailed directional hypothesis. I'm making a prediction and I've stated in which direction I'm going. Drinking the Red Bull will make you more talkative, right? A two-tailed hypothesis, or a non-tailed directional two-tailed, also as a two-tailed hypothesis, simply states that there is a difference between the conditions or groups of people. But unlike in a directional hypothesis, the nature of the difference is not specified. We don't know what that difference will be. So a two-tailed non-directional hypothesis would be people who drink Red Bull differ in terms of talkativeness compared with people who don't drink Red Bull. So we haven't said whether they're more or less talkative. We're saying that we're not sure. We're saying we don't know which way it's going to go. We're just saying that there is going to be a difference. You can decide whether you use a one-tailed or two-tailed hypothesis based on sort of the knowledge that you have already, essentially. The null hypothesis, so there's a third one. So we've got directional, which is one-tailed, which states what direction it's going to be in. For example, the Red Bull will cause you to be more talkative. We've got a non-directional two-tailed hypothesis where you say there will be a difference, but not stating whether that will be more or less, higher or lower, whatever. And there's a null hypothesis. The null hypothesis simply states that there is no difference between conditions or groups of people. That this hypothesis is accepted if the results of the experiment are not significant. So if we don't find the results, if we don't find any significant findings from the results, we accept the null hypothesis that there is no difference. So in our example of the Red Bull, it might be there will be no difference between people who drink Red Bull compared with people who don't drink Red Bull in terms of talkativeness. So there's two hypotheses. You might have a directional one and you'd have a null. You might have a non-directional and a null, and depending on what the results come, whether they're significant or not, you say, oh, I'm going to accept the directional hypothesis, or you're going to reject the directional hypothesis and accept the null hypothesis, which was I didn't find any difference. Okay, we've got directional and non-directional hypotheses. Lots of terms today, but it's important to know these terms because we're using them throughout the course, and if you don't know them now, you're not going to remember, and you'll be sitting there in class like, oh, it's getting a bit awkward now. I've been in the class and he's used this term like 10 times. I still don't know what it means. I don't want to put my hand up. It's going to be a bit awkward if I put my hand up, so I don't get what you're talking about. Right, so make sure you know these terms. It's important. A directional hypothesis states the, I'm going to go with direction of the I'm going to say relationship or difference. Difference or relationship. Yes, good. A non-directional hypothesis does not state the direction. There we go. Directional hypothesis states the direction of the difference or the relationship, and a non-directional hypothesis does not state the direction. Oh, we got a question. Application question AO2. Directional or non-directional? Decide whether the following hypotheses are directional or non-directional. What features or words in each hypothesis are important when making your choice? So let's have a look. We'll do it together. We'll do the first one together. Number one, there is a difference in children's reading abilities depending on whether they have blue or brown eyes. Right? Because it doesn't state whether it's going to be better for blue or better for brown or worse for brown or worse for blue, it's not stating the direction. It's just saying they will differ. So therefore, I'm going to go non-directional hypothesis. Yes. Okay. Number two, you're going to do this one now. Dogs that are rewarded with treats sit when told to do more than dogs that are not rewarded with treats. Okay. Is that directional or non-directional? What do you reckon? Say it out loud. I can't hear you. Directional. You sure? Yes, it's directional. Well done. Good. Did you say it out loud? You didn't. Come on, play along. Right, number three. There is a difference in the psychology grades of students depending on whether they are male or female. It says there's a difference. It's not saying better or worse for males or females. So this is a non-directional. Well done. Last one now. Right, last one, number 4. Teenagers who watch horror films have more friends than teenagers who watch romantic comedies. Right? Is that directional or non-directional? One-tailed or two-tailed? Think about the key words in there. Teenagers who watch horror films have more friends than teenagers who watch romantic comedies. Directional. You sure? Yes? Good. Directional. I'm pretty sure. Yes, I'm right. Good. I should know. Directional. A non-directional hypothesis in this example would be teenagers who watch horror films differ in the amount of friends than teenagers who watch romantic comedies, right? It's not stating which one has more friends. It's just stating that there's a difference. This one says that those who watch horror films will have more, therefore that's directional. Okay, doing an experiment. We have decided to test our energy drink theory by doing an experiment. Firstly, we are going to gather together 2 groups of people. Let's say 10 in each group, so 20 people total. Then, starting with the first group, we'll give each person or each participant, because that's what you call people in studies, a can of Red Bull to drink, obviously. What else are you going to do with it? The participants in the other group will have just a glass of water. So 10 people in your of your participants are having a can of Red Bull and 10 people are having water. We will then record how many words each participant says in a 5-minute period immediately after they have had their drink. Leaving aside the debate about whether or not this is a good experiment and the exact details of how it would work, which type of hypothesis should we choose? Right? Psychologists tend to use a directional hypothesis when the findings of previous research studies suggest a particular outcome. When there is no previous research or findings from earlier studies are contradictory or inconclusive, they will instead decide to use a non-directional hypothesis. Even though Red Bull is an energy drink, the effects of caffeine and sugar on talkativeness are well documented. Therefore, we will opt for a directional hypothesis on this occasion. So whether I decide to use a directional or non-directional hypothesis is based on previous research in this area. Yes, it is. And there we go, that's hypotheses, right? Identify one thing you learned about hypotheses, right? We had a look at lots of different words, directional, non-directional, null. Why do you think learning about hypotheses is important? Why is it important to learn about hypotheses? And how do hypotheses apply in real life? There's loads of research out there, right? And it's important to have your hypotheses to have your predictions. What questions has hypotheses raised for you? What are you still wondering about? You got any questions? Put it in an email to me if you want to. Maybe I'll respond. Maybe I'm busy. Is it the weekend? I'm sorry, I'm busy. No, I might not be. We'll see. Learning objective 2. Identify and analyze hypotheses. Can I take this one off? No? I'm going to do it anyway. There we go. We're on to learning objective 3. Independent and dependent variables, right? This is something you're really going to have to understand because it is something that comes up again and again and again, right? Independent and dependent variables. Let's get our head around this together. Therefore, we'll know the terminology, yes? Dependent and independent variables. If you need help, have a look in the textbook as well. 178 to 179. In an experiment, a researcher changes or manipulates the independent variable and records or measures the effects of this change on the dependent variable. All other variables that might potentially affect the dependent variable should remain constant in a properly run experiment. You said variable way too many times there, and the word dependent and independent. Yeah, I know. It's fine. It's fine. We'll get through this, okay? This is so the researcher can be confident that the cause of the effect of the DV, or the dependent variable, was the independent variable and the independent variable alone. This will make sense when I put an example with it, okay? Don't stress out. You'll be fine. It's just a lesson. Right, let's get the definition sorted first of all. Independent variable. Some aspect of the experimental situation that is manipulated or changed by the researcher or changes naturally, so the effect on the IV, the independent variable, dV, can be measured. Yes. Dependent variable, dV. The dependent variable is the variable that is measured by the researcher. The results. Any effect on the dV should be caused by the change in the IV. Yes. Good. Independent variable. Some aspect of the experimental situation that is manipulated or changed by the researcher or changes naturally, so the effects on the dV can be measured. And the dependent variable is the variable that is measured by the researcher, the results. Any changes on the dV should be caused by the change in the IV. Let's have a look at what this will look like in our experiment. In order to test the effect of the IV, we need different experimental conditions. If we simply gave participants Red Bull, how would we know how talkative they were? We need a comparison. We could either compare participants' talkativeness before and after drinking Red Bull, or compare two groups of participants who drank Red Bull with those who drank water. In either case, the two conditions are no Red Bull or drinking Red Bull. These are the two levels of the IV. So this is the independent variable. It's the thing we're changing, okay? Some of them will drink Red Bull, some of them will not drink Red Bull. That's what we're measuring. That's what we are changing. What we are measuring, which is the dV, is what? Talkativeness. Yes, good. Can't even talk. So there are two levels of the independent variable. You've got the control group, which is the no Red Bull group, right? The no drink of water, it's the drink of water group, right? And the experimental condition, which is the energy drink, all right? This might be a drug. If you were testing a drug, you would give half the participants the actual active ingredient drug, and you would give the other half participants a placebo, a fake drug, a Smartie if you want, right? Give them that. And then you're comparing the two, right? So we've got a control condition, which is the placebo, and we've got an experimental condition, which is the real drug. Same here, we've got the experimental condition, which is the energy drink, and the control condition, which is just a drink of water or no Red Bull. A well-written hypothesis should make it easy to tell what the independent and dependent variable is. Okay, we may proudly unveil the directional hypothesis we have written for our energy drink investigation. Okay, here's our directional hypothesis. The group that drinks an energy drink will be chattier than the group that drinks water. Okay, so the two independent variables, the two conditions are whether they drink energy drinks or whether they drink water, and the dependent variable is whether they will be chattier. And we've got a directional hypothesis. We're predicting which direction it will take, and we're predicting that energy drinks will be the people that drink energy drinks will be chattier than those that drink water. The group that drinks an energy drink will be chattier than the group that drinks water. Great, isn't it? Except it isn't really. What should also be obvious within a good hypothesis, unlike the one above, is how each of the variables have been operationalized in order to make the hypothesis clear and testable. Operationalized. What's this word, operationalized? It's basically, how do you measure? How are you going to measure the DV? How are we going to measure talkativeness, right? I'm not going to go, oh, they're talkative, they're not. That's not scientific enough. We need to operationalize it. We need to measure the talkativeness. How are we going to do this? Right, first of all, let's have a look at this application question. Application question, IVs and DVs. Identify the IVs and DVs in the example below. Okay, we should be able to do this, okay? The independent variable and the dependent variable. Remember, the independent variable is the thing that you're changing. The dependent variable is the thing you're measuring, the results sometimes. Okay, so number one, we'll do number one together. Talking to a child will increase their language abilities. Talking to a child will increase their language abilities. So, the thing that we're testing is their language abilities. So that's the dependent variable, okay? So we're measuring their language abilities. That's the dependent variable. The independent variable is therefore talking to a child, right? And then it depends on how many levels there are. You might have talking to a child briefly, talking to a child middle, talking to a child loads, right? Or you could have two. You could have talking to a child nothing and talking to a child constantly, right? You can have as many IVs as you want, as many conditions as you want. So let's see if we got that one right. Oh, we'll do it. All right, fine. We'll do number one. Number one, whether the child is talked to a lot or a little, and DV is the language ability. So there we go. Let's do the rest of them now. People are more aggressive on hot days, right? What's the IV? What's the DV? Write it down. We're going to go through it in a second. People are more aggressive on hot days. What are you measuring here? And what are we changing? What's the independent variable? Students may be late for school because they stayed up late the night before. Number 4, watching horror films will make children have nightmares. And number 5, people will be rated as more attractive if they wear red. Right, pause the video, give yourself 5 minutes. There's a timer there. If you've got the PowerPoint open, click the timer. Give yourself 5 minutes, try and answer those 5 questions. Right, let's have a look at the answers, shall we? Number 1, the IV was whether the child is taken, was talked to a lot or not, and DV was language ability. Number 2 was the IV was the daily temperature. What was the temperature? Was it hot or cold? That was what was changing. We're not necessarily changing it, but that's what was being changed. And the DV was the level of aggressiveness, right? Was the day being hot or cold affecting the results of whether they were their level of aggression? Number 3, the IV was the time the child goes to bed, early or late. And the DV was the punctuality, whether they were on time or not, whether they were late to school. Number 4, the IV was the type of film they watch, right? You're going to choose which film I'm going to show the participants. Is it going to be a horror film? Is it going to be a romantic film? Whatever. And the dependent variable is how frequently they have nightmares, or how many nightmares, or how long the nightmares are, which is nightmares. And number 5, whether wearing red or wearing another color would be more or might be more or less attractive. So the attractiveness is the dependent variable. How many did you get out of 5? You didn't get a 5, you liar. Right, there we go. Dependent and independent variable. If you're not 100% sure what those terms mean again, go through the slides again, or go through the textbook, read it through there. Maybe that'll make more sense, okay? Identify one thing you learned about the dependent and independent variable. Why do you think learning about the dependent and independent variable is important? How does the dependent and independent variable apply in real life? And what questions has the dependent and independent variable raised for you? What are you still wondering about? You got any questions? Right? Try and go through it again yourself. If you're not sure, maybe call up your mate. Oh, have you done Mr. Neo's homework? You have? What a geek. No, I'm joking. Do it, and then you can help other people out. Right, learning objective 3, to be able to differentiate between the dependent and independent variable. Yes, ticking it off, tick. We're on to the last one now, operationalization. This is where we got to before. So we're on to learning objective 4, to understand how to operationalize variables. Ooh, operationalize, that's a difficult word. No, it's fine, we'll be fine. Operationalization of variables. What a lovely long word that just rolls off the tongue. Operationalization, easy. Many things that psychologists are interested in, such as social behavior, intelligence, or thinking, are often a little fuzzy and not easy to define. How do you measure these things? Thus, in a study, one of the main tasks for the researcher is to ensure that the variables must be investigated are as unfuzzy and measurable as possible, i.e., operationalized. So, a much better hypothesis than the one before would be, after drinking 300 milliliters of Red Bull, participants say more words in the next 5 minutes than participants who drink 300 milliliters of water. You see how we've operationalized those variables there? The variable of Red Bull and the variable of time, we've given them specific numbers, right? 5 minutes at 300 milliliters. See the difference? Now that our variables are operationalized and our hypothesis is written, we are free to concentrate on more important things, such as how on earth are we going to count all the words that 20 people say in 5 minutes? Okay, so we're operationalizing talkativeness, right? How do you operationalize talkativeness? How do you measure someone's talkativeness? And that's what we're doing. Oh, well, we're going to do it by counting the physical, those literally amount of words they say in a 5-minute period after they've drunken their drink, whether that be Red Bull or water, right? We're operationalizing talkativeness. The same way, if I was to, how am I going to measure intelligence? How do you measure intelligence? It's such a difficult thing to measure. Oh, it's, how do I do this? Well, you can give someone an IQ test. That's a way of operationalizing intelligence. You give them an IQ test. The IQ test, they do the test and it gives them a number. It gives you a number to work with. That's what operationalization is. It's giving you a number that you can work with. I can't go, they're more talkative, they're less talkative. That's not very scientific. It needs to put a number to it. Operationalization is putting a number. Oh, they said this many words, or they got this score on the IQ test. That's how you operationalize some variables. Operationalization, how do we define this, right? We understand it, but we've got to put it in a definition term now. Ensuring, I'm going to go variables, yes, are in a form that can be easily measured or tested. Yes. Clearly defining, yeah, cool, variables in terms of how they can be measured. Oh, I gave the example that I put earlier. Intelligence may be operationalized with an IQ test, putting a variable into the measurable number. Yes, right? It's putting it into numbers. Application question. Oh, there's loads here. For each of the 5 aims of the investigations below, operationalize the IV and DV and write a directional and non-directional hypothesis. Wow, that's going to be long. Okay, let's do the first one together and you can do the rest on your own. So number 1, to investigate whether high confidence levels in children affect their levels of obedience. To investigate whether high confidence levels in children affect their levels of obedience. So the IV is confidence levels, because that's what's changing. Some children have high confidence, some children have low confidence, and that will affect their levels of obedience, which is the DV, the dependent variable, what we're measuring. How obedient are they? Okay, so let's start with trying to operationalize. Now there is not one way to operationalize these variables. There's lots of different ways. The answers I've given are just an example. So to investigate whether high confidence levels in children affect their levels of obedience. So confidence levels. The easiest way is usually give them a questionnaire. Give them a questionnaire that measures confidence levels. You give them a questionnaire that measures obedience. Or you could do something where you ask them to do something and whether they do it or not, that's going to show their level of obedience. And if we were to write a directional or non-directional, a directional would be individuals with high levels of confidence will be less obedient, I would assume. Or a non-directional hypothesis would be participants with high or low levels of confidence will have a difference in their level of obedience. Let's have a look what I got for the answer. Number 1. To investigate whether high confidence levels in children affect their levels of obedience. So the IV, is the score on a confidence scale. So I said a questionnaire could be a confidence scale. The DV is the number of instructions from a teacher obeyed. So it could be anything. You could make your own way of measuring or operationalizing the dependent variable. A directional hypothesis: the children who score over 50 on the confidence scale obey more instructions from the teacher than the children who score under. They went for the other way. They said the more confident obey more. I thought the more confident would obey less. Non-directional hypothesis: there is a difference in the number of teacher instructions obeyed between the children who scored over the 50 on the confidence scale and the children that score under the 50. Okay, have a look. I try and do questions 2 to 5 on your own. Here are the answers. Do the questions first. Have a look here. Here are the answers. Number 2, I'm not going to read them through. Number 3, pause the video if you need. Number 4, there you go. And number 5, you're welcome. Right, there we go. Operationalization of variables. Identify one thing you learned about operationalization. Why do you think learning about operationalization is important? How does it apply in real life? Well, if I was to conduct an experiment, I need to operationalize my findings, don't I? I want to find out if eating more chocolate affects how beautiful I am, or something like that. How am I going to operationalize beauty? Always a really difficult one. Maybe I get people to go and test, give a score out of 10 or something like that. What questions has operationalization raised for you? What are you still wondering about? You got any questions? Let me know. Right, learning objective 4, to understand how to operationalize variables. Let's tick that one off, and we are done with the lesson, with the exception of the plenary. Last bit now. Question number 1. Which statement is the non-directional hypothesis? Is it A, females are more accurate in judging the speed of a car than males? B, females are more accurate in judging the speed of a car than females? C, there is a difference in accuracy of judging the speed of a car between males and females? Or D, females are more accurate in judging the speed of a car than males? What's the one that doesn't say more, or the one that doesn't say more? So it's going to be, what do you reckon? C, there is a difference in accuracy of judging the speed of car between males and females. Yes. Number 2, an experiment investigated whether close proximity to strangers increased heart rate. The DV would be what? A, proximity of strangers. B, the strangers. C, the heart rate. Or D, the participants. What would the DV be? What are we measuring? We're measuring the heart rate. So C. Yes. Number 3. Which would not be an effective way of operationalizing aggression? A, number of punches thrown. B, number of expletives used, that's swear words. C, distance someone stood from someone else. Or D, facial expressions. That's a difficult one. I've got one in mind. What do you reckon? D, facial expressions. Because how is that operationalized? How have I put that into numbers, right? A facial expression, how can I put that into how can I give that a score, right? Number punches thrown, I can count that. Expletives used, swear words used, easy. Distance someone stood from someone else, I can measure that. Facial expressions, how do I measure that? That's not a measurable, that's not operationalized, is it? Number 4, an effective experimental hypothesis should include A, clearly operationalized covariable. B, a clearly operationalized dependent variable. C, a clearly operationalized EV. Or D, a clear aim. What do you reckon? A, B, C, or D? D, yes, an operationalized DV. An operationalized IV would be great as well. Number 5, in an experiment that tested whether diet affects how fast someone can throw a ball, the operationalized DV would be A, the mean daily number of calories participants consumed. B, the diet. C, ball throwing ability. Or D, how far participants throw a tennis ball in meters and centimeters. It should be D. Yes, how far participants throw a tennis ball in meters and centimeters. That's been operationalized, right? So it's how far they can do it. That's the operationalized DV. That's what they're measuring. How far can someone throw the ball? And the last one, number 6, match up the following terms with the correct definitions. We've got IV, DV, control group, and operationalization. On the right, we've got variables being investigated should be clearly defined and measured. The variable that is measured by the experimenter. Used for the purpose of comparison to determine whether the IV affected the DV. And then the variable that is changed or manipulated by the experimenter. So IV is the variable that is changed, correct? The DV is the variable that is measured by the experimenter. Good. The control group is used for the purpose of comparison, right? A control group is the one that you're comparing the experimental group with. And then operationalization is obviously being able to measure the variables. There we go. How did you do it? How did you get out of 6? How many of the questions did you get correct out of 6? Are you an absolute legend? Watch the following experiment, identify the hypothesis, the IV and the DV, and how they operationalize the IV and DV in this experiment. if you can, that is, right? Watch the experiment. It's a fun little experiment. It's quite nice to do. And there we go. That's the end of the lesson. The next lesson is going to be control of variables. Thank you for joining today's lesson. You've been absolutely brilliant. Be sure to write up the notes for today's lesson. Well done, my neo-psychologist. Great job today. I've been Mr. Neo. God bless and peace.
I'm feeling like Will. I feel like a prince. I'm feeling myself. I'm loaded with bills, cause I wasn't blessed with no Uncle Phil. Don't know how it feels. I wanted to flex, they told me to chill. I'm making a flip. My life is a flick, now load up the film.